Okay, we're just at the start of this lesson. We're going to recap really what we've done the past couple of lessons. And we're going to try and link what we have learned about resultant forces to Newton's second law. Okay, Newton's second law is simply written as this: resultant force equals mass times acceleration. Now we can rearrange it actually to give us that the acceleration is the resultant force divided by mass. Key things to remember is that this mass has to be in kilograms. And the key thing in this one has to be in newtons, but it has to be the resultant force. And that's how we're going to change things this week. So let's look at an example where we have a car and we're told that the thrust from the car, the forwards force thrust, is, let's say it's 4,000 newtons. And the mass of our car is, let's make it 3,000 kilograms. But we're also told there's another force on the car, which is the drag, which is the 1,000 newtons. And we are asked to find out what is the acceleration. Now, it's not too complicated, but there's an added step in here in that we've got the mass. We want to find the acceleration, so we're going to use Newton's second law. But the key thing here is that it is the resultant force we need in that equation. And we haven't been given the resultant force yet. We have a forwards force of 4,000, that can be called the thrust, but that's not the resultant force. We've got a backwards force of 1,000, but that's not the resultant force. That's drag or friction, you might call that. So the first thing we need to do is find the overall force on that. And if you remember, the forces are going in the same direction we add them. If they're going in opposite directions, we subtract them. So in this case, the 4,000 newtons is forwards, the 1,000 newtons is backwards, which gives us a resultant force of 3,000 newtons. And it's only this that we can use in our equation down here. So we then write out the equation again, put in the things we know. We know the resultant force is 3,000 is equal to the mass, which is also 3,000, and that will allow us to find the acceleration. Here we have 3,000 A's, okay, 3,000 times the acceleration. We want that, I mean, you probably look at this and see that it's going to end up as 1, but let's go through the steps. We want this to be just 1A. And how I do that, if we just even ignore this other side for now, if I have 3,000 A's and I want to make them into 1A, all I do is I divide this side by 3,000. But if I do that to 1/2 of an equal sign, I also have to do it to the other side. So that then leaves, just to go through all the steps, 3,000 divided by 3,000 equals our acceleration. 3,000 divided by 3,000 is just 1, and acceleration is measured in meters per second squared. Okay, so you will get some questions where you're not given the resultant force. You're given a system of forces. You're given all the forces that act on the object. Before you can use Newton's second law, Rf equals ma, you may have to work out what the resultant force is. So there's kind of 2 steps. Step 1, work out the resultant force. Step 2, use that to work out the acceleration of whatever it is the question is asking you. The other thing you could be asked to do, so let's get our car again. Let's say we are told that the backwards force due to drag, let's keep it at 1,000 newtons. Okay, so we've got a backwards force of 1,000 newtons, and we're not told what this forwards force T is. Okay, but we're told that the car has a mass, let's stick with our same values, of 3,000 kilograms, and we're going to say that there's an acceleration of 2.5 meters per second. So really what this question is asking you is, what does this forwards force T have to be, the thrust, so that the car will have an acceleration of 2.5, given that there is a backwards force of 1,000 newtons. Now, if you notice here, we have the mass and we have the acceleration. And when we have those 2 things, we can use Newton's second law. So this time, the first thing we do, step 1, is to use Newton's second law because we have the mass and the acceleration. And that tells us that the resultant force is 3,000 times 2.5. Type that into your calculator and it will give you 7,500 newtons. So those three pieces of information, mass, acceleration, and resultant force, are all linked through Newton's second law. We know that if we have a resultant force of 7,500 newtons, and the mass of the car is 3,000 kilograms, we will get an acceleration of 2.5 meters per second. However, that's not what this question has asked us. This question has asked us, what is T, the forwards force here? Now, the mistake people will make here is they will see the 7,500, they'll see a backwards force of 1,000, and decide that T must be, well, that force is backwards, we'll subtract it, and we'll get that this is 6,500 newtons. But if you look at this system, forwards force is 6,500, backwards force of 1,000, the overall resultant force of those two is 5,500, which is not what we need here. So take your time when it comes to these types of questions. And what I would do is I would just ignore all the stuff that we have done in our calculations. Just look at our car here, and I would just write a sentence saying the resultant force in that car is going to be the forwards force T minus the backwards force 1,000. Okay, but we worked out from Newton's second law that the resultant force needs to be 7,500. So I can write this out again, but I can put in the 7,500 for my resultant force is equal to T minus 1,000. I want to find out what T is all by itself. So what I do is I add 1,000 to this side of the equal sign, and I add 1,000 to this side of the equal sign. I'll write it in full. So 7,500 plus 1,000 equals T. Therefore, T is 8,500 newtons. Okay, the thruster forwards force is 8,500 newtons. Put that into your system of forces and just make sure that it works. So if this is 8,500, forwards, backwards force of 1,000, the resultant force will be 7,500, which is what's required to produce that acceleration. In both of these cases, the key thing to remember is Newton's second law only deals with resultant forces. So if you're not given the resultant force, you might have to work that out first of all. If you're asked for something that is not a resultant force, just a forwards force, you usually have to work out the resultant force using Newton's second law first, and then work out what that force must be to produce that resultant force. Just be careful with the wording of particular forces. So thrust, we usually take for like a car, a bus, a boat, a bike, whatever type of transportation it is the forwards force. Okay. The only case where that would not be so is if you're dealing with a rocket. Okay. So if we have a rocket that's trying to move upwards, we would take the thrust to be the upwards force in that case. Okay. But in most other cases, like a bus or whatever else, the forwards force is going to be T. Okay. Other forces then that come into play is we have backwards forces due to friction. So if this is trying to move forwards, the backwards force due to friction might be called friction, but it could also be called drag. It could be called air resistance. There are just different names for that backwards force. Remember, none of these are resultant forces. We would have to add or subtract them to work out the resultant force. The other one that can come into play for rockets is there is a downwards force due to gravity called weight. Okay, it's a force, it's measured in newtons. Remember, mass and weight are different things in physics. So you might have a system of forces where you have a forwards thrust upwards and a downwards force weight when it comes to rockets. Okay. These questions are getting more difficult. The content we're doing is getting more difficult. This is some of the harder content that is on the GCSE course. Try and get as far through the questions as you can. Don't worry if you're not getting all the way through it, but you should be able to extract some of the information, write out an equation, try and put some numbers in, and at least try and get halfway through most of the questions. So if you find them difficult, don't worry too much, give it your best shot, and then we will do a little video explaining the answers next week. Okay.